my seat, what I would be doing was saying to myself, performance is a function of preparation. I need to go about my business to the best of my ability, and then let the chips fall where they may, whatever happens. If I'm a jerk and I affect your grade, so be it. That's not gonna happen, but I do have very close friends, and I have kids that I know very well, whose teachers intentionally try to trick them on tests. And it's horrific when that happens, because you work so hard and you don't achieve at the level you want to achieve at. What I want you to do as we go over this, if there's something you got wrong, you need to star it, circle it, exclamation, whatever it is, and you need to write a note on your paper to redo that question and learn to get it right the right way. This is what a lot of kids call preparation. We're gonna go over all the questions to the pretest the other day. And let's say you got 5 of them wrong. Kids will look at the 5 they got wrong and go, oh, I see what he's saying, and they'll never look at them again. That's not preparation. That's revelation. Oh, I got them wrong. Preparation means it's revealed to you that you need to learn something, and then you roll up your sleeves and you get to work. You come to extra help. You prepare thoroughly. You do everything you have to do to make sure that when you see such a similar question on the test, you can crank. Now, here's a really important proof of this, and it's not even what I'm saying. You don't even have to take my word for it. The pretest, or I should say the first test you took this year, there were 2 pretests plus the test. I gave them to you. I told you they would look exactly like the test, yet some people got disappointing grades. Then they did the relearn packet. And after the relearn packet, they were, for the most part, with one exception, and that person on the second time did awesome. They were ecstatic with their grades. They were like, man, I went from a 68 to a 96. I went from a 72 to an 88. Do you know that the relearn packet was exactly the pretest? I didn't change a question. Exactly the same stuff I gave you before the test. So when you prepared thoroughly for the relearn packet because you knew, oh my God, if I don't do this, then I'm gonna get a bad grade. When you went about your business the right way and came to extra help and asked questions, ha ha, your grade skyrockets. I'll be. How the heck did that happen? But when you didn't take it seriously, you did eh. So what I want you to focus on over the next 3 days is how you prepare for the test. Everything you get wrong needs to be addressed. And you need to know why you got it wrong, and you need not to repeat that kind of mistake. If you do that, you will kick us, butt us on Wednesday's test. If you don't do that, you'll have a problem. Spencer,
When's the test?
if you do that on Wednesday's test, you said that to see if I'm losing my mind, didn't you?
No, I actually forgot.
You
All this
did.
talking about preparation is scaring me.
Common sense ain't so common. Okay. Now, let us. Oh, that's not the right one. Why are they not coming out in order here? All right, that's not it. All right, so I will find page 1 very shortly. Yes. Ordinarily, I would say no, but I'm going to allow it this time. But you better run. Dig it, dig it, dig it, dig it, dig it. Good morning. Did you happen to speak to Dave Qrtr?
No, I'm not.
Dave Qrtr did this.
Informal?
Yes.
15 minutes.
Yes, and I even said to him that you had come down here, and because he walked in the door and I went,
Right.
and he goes, oh, I'm here for your informal. I said, I don't know so much about that. And then I said, well, you need to speak to you, and he said he was going to take care of that.
All right.
All right? So I'm sorry that,
Sorry to interrupt.
yeah, all right?
All right, we'll figure it out.
All right, see you later. All right, so this isn't it. Where is page 1? It was the first one done. Oh, here we go. All right, maybe I clicked on the wrong button. So let's get out your pretest. Spencer, can you hit that door, please? Let's get out your pretest and go through each of these things step by step so that we know what we're doing. Okay. Now, Number one, if there's any questions, please stop me and do not be afraid to speak up. We all make mistakes. We all screw things up. Performance is a function of preparation. If there's an error, say something, and we want to straighten it out so it doesn't repeat on the test. Any problem with number one?
No.
Okay, number two, I'm betting there's problems on number two.
No.
I'm betting some of you guys chose one.
Yeah. Of
Yeah. He's not listen, let me explain why he's not standing still. Ready? First off, this is an old Regents question. Whenever you see font like this means it used to be on an old Regents exam. This is why. Look, what does this axis over here on the left represent? Anthony?
It represents the speed of the jump.
That's right. If you look here, isn't the speed staying 6? If the speed is 6, how is he standing still? Now, if the axis said distance, then he would be standing still because the distance would be staying the same. But it doesn't say distance. What does it say? Speed. So you need to make sure you look at what the units are or what they're measuring on this axis so that you don't repeat those mistakes. Okay? All right, make sense to everybody? All right. Now, how many of you know that if you were lazy and a bum and didn't concentrate on this and didn't put a little note on your paper, that there's a pretty good chance you might miss that again on the test. But if you prepare thoroughly, is there a chance in the world you miss that? No, not a chance. Okay. What about number 3? Did everybody get 3?
No.
All right.
Yeah, that was so
It's easy if you remember one thing, Anthony. But if you didn't remember the one thing, it's darn near impossible. Carissa, what's the one thing?
Well, I had a question.
All right, hold it. Carissa, go ahead.
Okay, well, I got it right, but so if there's 2 outputs, then it's not a function, or?
Inputs. You're not allowed to have, the same input cannot repeat. The rule for a function, listen, hey, look at me. The rule for a function, every input must have one and only one output. It cannot have 2 different outputs. So look on choice 1 here. What's the first output for 2? 3. What's the second output for 2? 7. That can't be, that's not a function. It's called a relation. Look at choice 2 here. 0 goes to 0, 0 goes to -1. Look at choice 4. 0 goes to 0, 0 goes to +1. But if you look at choice 2, 3, 5, 7, 9. None of the inputs repeat. Therefore, they each only have one output. Therefore, choice 3 is the only one that's a function. Make sense? Okay, good. All right. Now let's go to, I'm going to hope to get the next one in order. Yep, good, we got it in order. All right, so number 4 is choice 1, and I'm willing to bet some of you got that wrong. So let me go through and explain this to you so that we obviously don't make these mistakes again.
I know the reason why.
Go ahead, Ant.
The reason why is because you have to be less than or equal to. You have to be greater than or equal to 5, but less than 7.
Right, what happens on that 7th birthday?
You move up to the next.
That's right. So look at what this graph says, choice 1. The day you turn 5, you're allowed to be in this group. You keep staying in the group until you hit 7. What happens on 7? You jump up. Then you stay in that group until the day you hit 9, then you jump up. Look at the other choices. This choice here, Spencer, door. I meant to tell you, you can feel free to watch.
Well, that's because that was a popping.
Oh.
I'm actually gonna.
Oh, okay. All right. So, ready? So go back to here again. Ready? Take a look. For choice 1, every time we hit the age of 7, it jumps up. Hits the age of 9, it jumps up. So on the 9th birthday, what's happening? Spencer?
He's going up 1 addition.
That's right. And doesn't that match the description in here of words? Right? On the next odd birthday, he is what? Required to move up, which is exactly what he does. If you look here on choice 3, when he turns 7, he's actually in 2 age classes. Is that possible?
Nope.
No. If I look here, oh, he's not even in an age class here. How do I know he's not in an age class on choice 4? Janelle?
The circles are not filled in.
That's right, exactly. And then on choice 2, we're backwards. Because on choice 2, on his 7th birthday, he's still allowed in the previous weight class. Okay? Question?
Oh, no, no.
All right, so here's the thing. We just told you a minute ago, performance is a function of preparation. Performance is not about aiming for a particular grade. Performance is going about your business the right way. And then I said to you, you should be writing notes like crazy on any question you got wrong. And then I said, I'm willing to bet people got this wrong, and lots of hands went up. I'm gonna pause for a second. Write yourself a note about what you did wrong. Okay?
I'm still confused.
Okay, hold on one second.
Yeah, me too.
Did you have an answer you believed in?
What?
Did you have an answer you thought you knew was the answer?
Well, I asked my mom for help, she thought it was 3.
Okay, let's explain why it can't be 3. It can't be 3 because on his 7th birthday, which division is he in?
And then the first one?
Really, because this is filled in also.
It can't be in two.
Now, that's right, you can't be in 2 divisions at the same time. Does that make sense?
Yeah.
All right, did anybody choose another choice that they thought was it?
2.
2. Well, the problem with 2 is this. Do you see how it says here, until his next odd birthday, on that birthday, he is what?
Required.
Required to move up. Look over here. Ready, Sydney? Here we go. We get to the odd birthday, he's supposed to move up. But if I go up, that circle's not filled in, which means it doesn't equal it, right? So he has to stay in his weight class on the birthday. It's only when he gets past the birthday.
Oh, okay.
All right? I hear learning. I like this. Janelle?
I think one thing that we really need to look at is if the 5 is filled in, because it says Morgan can start wrestling at 5 in Division 1, so he can. So that means it should be filled in, because if the circle is not filled in, it's telling you that he can't start at 5.
This is a
And that
great
goes
point by
against-
Janelle. Do you understand what she's saying? He starts at age 5. Well, here, it's filled in on age 5, so he can wrestle. Is it filled in on age 5 here? No. So on the day he turns 5, he wouldn't have been allowed to wrestle. Yes?
So an open circle means you're required to?
The open circle means you're not allowed to equal it,
Okay.
right? Just like when we do graphing the inequalities, if it has the little line underneath. Ready? If we're graphing an inequality, and, oh, sorry about that. And I'm sure that you will. Oh. Here we go. Ready? If we want to graph n is greater than 2, 2, open circle, arrow to the right, right? What do I make it for allowing to equal? What do I have to do?
Closing the circle.
That's right. Well, when I'm closing in the circle here, that means at 5 he's here. When I have 2 closed circle here at 7, that would mean he would be in both divisions. That can't be. So when it's an open circle here, what Janelle is saying is he wouldn't be allowed to wrestle, even though he's 5 years old. But over here, is he allowed to wrestle?
Yeah.
Yes. Okay. Any more questions? Are you writing yourself a note on your paper if you got that wrong? Okay. All right. Very good. What's performance a function of? Preparation. Very good. Prepare. If you prepare, the results will follow. Okay. This is a question that's kind of new to us. And I'm wondering how many of you guys were able to get this right?
I didn't even know how to start.
I got
Okay.
5.
Lena says she didn't know how to start. Let me tell you how to start. You ready? Hold it. Hold it. What variable represents input, X or Y? What is it? X. Good. So what I want to do at this point in time is I want to look at this and I want to see what X's are covered by the graph. So if I take like an iron or some piece of wood, some flat piece of wood, and I just smoosh the graph down to the x-axis and see what part of that x-axis is covered. Wouldn't it start here and notice it's filled in, right? Right, we've been over how important that is. And then, wouldn't all of this have something smushed onto it? Would the points out here have anything smushed down onto it? No, absolutely not. Okay, so in other words, since this is the x-axis, and x is the inputs, and the domain is the set of all of the inputs, I want to know what inputs, what x's are covered. In other words, what they're smushed down, and there's this fancy math word, onto, that you'll learn about in future years. And if I smash this down and I look at this, well, first off, the values of x here are like -4, -3, -2, and look at this choice. I can have numbers that are smaller than 0, can't I? Yeah, so those choices can't do. What's the difference between choice 3 and 4? Cindy?
4 can be greater than or equal to.
Right, and 3 cannot be. Was I allowed to equal -4?
Yeah.
How do I know I'm allowed to equal -4?
It's a closed circle.
Because it's a closed circle, so what's the correct choice?
4.
4. Are you writing those? AJ?
Just, I think put in x for everyone, and since you can't have a negative square root, -4 + 4 is 0, you can square root of 0.
Good idea. What I just explained to you was the graphic approach. What AJ's talking about is more of an algebraic approach. He's saying, you know what, the graph is great, but I'm gonna focus on the equation they gave me. And by focusing on the equation, what he said is, I could plug in a 0 and the function will work. But if I plug in a -4, what should we call it? Oh, I could plug in anything greater than or equal to a -4. I couldn't plug in a -5. I couldn't plug in a -6, because then I would get a square root of a negative. And we've talked a little bit about, we went back when we did square root graphs, we talked about this. But can everybody just get your calculator out for a second? And I want you to type in square root -4.
What's the parentheses?
Just do square root of -4. And what does your calculator tell you?
Error.
It says
No,
error.
That's right. There's this, do you remember we had Colonel LaRocque in the other day, right? Did we tell you, do you remember where Colonel LaRocque used to teach mathematics? Anybody remember? Good.
West Point?
West Point. He's in here, he's talking to you about feasible solutions. Does everybody remember that? Right, we talked about the battalions and where to best allocate your troops for the money that the Congress says that you're allowed to have. So what happens is, he talks about feasible solutions, in other words, possible solutions. And then we've talked about square roots. Is it possible to find the square root of a negative number? No, because, first off, the calculator can confirm it by you typed in the square root of -4 and it said error. But square roots mean the number multiplied by itself. If you do a positive times a positive, what kind of answer do you get?
Positive.
And if you do a negative times a negative, what kind of answer do you get?
Positive.
So how could you square root a negative?
You can't.
Right. And except as you go up in mathematics, there's these things called imaginary numbers, but they will not become part of what you learn until you do algebra 2. Now, with that in mind, this graph, because this graph doesn't cover any of these numbers out here that when plugged into the formula would create a negative, that's why we can only go from -4 up, an increase in value, okay? But all of that said, AJ, if I was teaching this to an 11th grader, I would explain it the way you just did. And I'm not saying your way of understanding it's wrong, it's great, it's awesome, it's actually a step ahead. But I do want you to understand the idea of smushing the graph down. Because later on, I can give you a graph without a function. And you won't have the luxury of thinking the way you just taught. So make sure you understand about what part of the axis is covered. And if it's not covered, then it can't possibly be part of it. All right, now we start getting into some questions that I think are a little more routine. The kinds of questions that we have done so frequently. So I think we're going to be able to pick up pace just a little bit here. Number 10, how are we looking? Oh, number 6, I'm sorry.
Good.
We're good? Okay. So now, let's go to the third page of Thursday's pretest. Take a look. Teaching makes you bald. I don't know if you know that or not. If you missed number 7, you're contributing to my baldness. All right? With number 7, later in the year we will do it algebraically, but for now, all we need to do is use the calculator and we can look at the table for the zeros, or we can look at where it crosses the x-axis, okay? Anybody want to explain how they got the right answer to number 8? Because this is a little ahead of where we are in the course. Anthony?
Well, basically what I did is that I knew it couldn't couldn't be numbers 3 and 4 because because you were multiplying them, so it could only be exponent answer. So when I tried to
Let me rephrase that. Did you hear what Anthony just said? He said it couldn't be linear, because linear grows by a constant rate, right? Does that look anything close to constant? Not a chance. So he immediately blows through 3, 4 are not the answer. Keep going.
So anyway, when I tried to put in like 2 and 4 for 25, apparently that didn't work because when I did 25 squared, I got 625, so I knew that could be the answer. Then when I did 25 to the power of t plus 1,
Then it worked.
yes, it worked.
Perfect. Now, here's what I'm trying to do at this point in time. We are approaching this mathematics on 2 distinct levels. I learned a long time ago from a great baseball coach. The more you make practice like the game, and the more you make the game like practice, the more successful your team is going to be. The fact of the matter is that listen, I want to go theoretical math all year long, and I wish we didn't have a Regents exam at the end. But we do have a Regents exam at the end. And we need to be prepared for that test. And there are certain test-taking skills that we need to master. And one of those test-taking skills is checking out your choices, eliminating choices that we know can't be. That was the first thing Anthony did. He looked at it and said, well, that's not linear. So he blew out choices 3 and 4. Then he substituted the values into the remaining 2 choices. So if you were to look at the question without the choices, I think you would all say to yourselves, oh my God, I can't do this. By the way, later in the year you will. I will show you a trick on your calculator that makes this the easiest question in the universe. But that doesn't mean you can't do the question. It means you need to go to test-taking skills rather than plain mathematical skills. Why do I give you a question like this now that you're technically not prepared for? Because I want to build into you the ability to understand how to react to a question that seems unfamiliar. So that when you take your Regents and they specialize in creating unfamiliar questions, you have strategies that allow you to look at these questions and say to yourself, I got this. I got this. There is no need for panic. Okay? And how are we looking on number 9? Okay. Very similar to what Anthony was just saying and the skill that I was just talking about. For number 9, let's see if we can make sure we understand exactly what the question is asking, before we go forward, okay? What the question is asking for number 9 is this. Given these 2 functions, at which of these values for x, is the f function less than the g function? In other words, the output of the f function, f of x, the output of that particular input x. What is it, for which of these functions is it less than the g of x output? So I'm going to show you 2 choices, and then you can practice this at home, because I want to make sure we get through this. Let's plug in a 4. What is 3 to the 4th? You do it in your head, you can do it on your calculator, whatever you, not 16, no.
32.
It's 27 times 27.
Not 27 times 27, 27 times 3. 81.
I'm good.
Now, 2 times 3 is 6, 6 plus 5 is 11.
Well, I thought we were doing 4.
We're doing this? Oh, I'm sorry, we're plugging in a 4. 3 to the 4th is 81. 2 times 4 is 8, plus 5 is 13. Is 81 less than 13?
Nope.
No. So f is not less than g here. Let's try this one too. 3 squared is
6, 9.
9.
Oh, God.
2 times 2 is 4, plus 5 is 9. Is 9 less than 9?
Nope.
No. But let's plug in a negative 1. 3 to negative 1 is 1/3. And if you forgot that, you have your calculator. 3, caret button, up arrow, negative 1. It'll tell you 0.3 repeating. If I plug it in here, I get 2 times negative 3 is negative 6. Pardon me. 2 times negative 1 is negative 2. Plus 5 is 3. 1/3 is less than 3. Therefore, choice 1 is the correct solution. Yes?
I don't know how I got that right, because I thought that I was playing it wrong. I might have just got lucky, but.
Yeah, and here's the thing. Remember we just said performance is a function of preparation? You did get lucky. And you should have a note on that paper that says, understand why. You know, hold on. You know what I would do, in all honesty, if I were you? I would go home tonight, and I would use the slide, I would watch the video, and I would use the slider on the bottom and make sure I reviewed every single question I got wrong. Does that make sense? Right, that's a good way to go over it. Okay, how are we on numbers 10 and 11? Jane, up?
On 11, I don't know, like, I did the process, right?
Uh-huh.
But my math skills, my simple math skills are like very off, and I got 2n to the third instead of 2n to the 9th.
Well, did you get n to the 14th and n to the 5th?
No, I got.
Okay, well,
n
that's definitely the problem.
Oh, God.
Did you get n to the 12th here?
Yeah.
Good. Did you get the n squared's here? The rule is when I multiply coefficients, that's how I get 64, but I add exponents.
Why did I subtract? I didn't get it.
I don't know.
Okay.
Okay, Kaylee.
I don't understand how to do 10.
Okay, for number 10, it says here, solve for, or what is t in terms of a and d squared. So what I'm going to do here is I'm going to start with the equation, d is equal to 1/2 at squared, okay? Then, the first thing I want to do is get rid of the 1/2, because I don't like fractions, okay? So I have to multiply by 2. So if I multiply the right side by 2, what do I need to do to the left side? Multiply by 2, which I did, good, die. I get 2d over a is equal to, 2d is equal to at squared. But I want to get the t by itself, so then I have to divide by a. So that's the next thing I do. But that leaves me with t squared equals 2d over a. How do I get rid of the squared? I do the square root, because that's the inverse. So I square root it, and notice square root of 2d over a, square root of 2d over a. Oh, I'm sorry, just okay? Lipstick?
I don't know what I did for 11, but I got 128 and.
This is what I think you did, okay? I think you took the 4, I think you took the square here, and maybe squared the 4 to get 16.
Well, what I did is I multiplied 4n squared times 2n cubed.
Oh, and then, yeah, but then you would have violated the order of operations. Because the order of operations says you have to do the exponent before you do the multiplication.
But 10,
Okay? Cindy?
Did you get 64n? Did you do 4 times 69?
Oh, the reason I got 16 here is 2 to the 4th is 16. And then power to a power multiply, n to the 12th. And then 4 times 16 is 64.
Okay.
Okay? All right, so now let's go to the next one.
10 again, because I didn't understand like that, how you did the.
No, we can't, because we're running out of time. But you can watch the video. All right, if I had more time, I would. All right, hold it. I want to get to the next thing here. Take a look at the bottom one. Everybody, I think that's pretty easy, right? AJ, anything about number 12? Because I don't want to do anything before 12. Yeah, you finished that for homework. Anything with number 12? Go ahead.
How did we do that?
3 consecutive odd integers, x plus 2, x plus 4. And then it says their sum is 27, so I add them and I get 27.
But it doesn't say odd,
Yeah,
it
no,
says
this is
three consecutive.
Oh, sorry, I thought it said consecutive odd. If it says consecutive, x plus 1, x plus 2, 9, 8, 10 would be the answer.
Okay, I didn't get it right.
Okay?
Thank
All right.
you, I got 21, I don't know how.
All right. None you worry. Okay.
I don't understand it.
I just wrote 8, 9, 10.
Okay. Take a look at this one, guys. This is very much review work.
Where are we?
Yes.
Okay, I always get confused, so like, I got the zeros right.
Good.
Like, do you have to like list it as coordinate, or can you put n?
You do not, absolutely never list the zeros as a coordinate. The reason why is really simple. Aren't they 2 different points? How can I write 2 different points as a coordinate? Okay, just remember that, and you
Plus,
won't.
if I put n, like -1 and 3, would that still be correct?
Oh, and the word A and D? Yeah, that's fine.
Oh, okay.
Okay? Any other questions? All right, let's go to the next one. All right, I noticed the other day kids saying they didn't know how to do this one.
Yeah, what about 14?
Oh, I'm sure it's one of the other pages. So,
It was on the same.
oh, it was on the previous page?
Yeah.
Yay! Oh, wait, no, I got that.
I can't believe I got that right.
Wait, that's the area?
Yeah, did you have to get the width and the length and then multiply. All all right?
I just got the link.
Yeah, make sure you answer the question, okay? All right. Now, okay, hey. So the function one is gonna be, it's $6.50 per ticket, so 6.5 times X, plus you bought 12 tickets at $4 each, which is $48. So that's the function that tells you the total amount of money that's gonna come in. Any questions? Okay, number 16, we had homework questions like this earlier in the year, but it's been a while since we did them.
Oh, great.
We just did 15.
We did too fast.
I don't understand.
Guys, come on, head in the game here. I just explained to you that each ticket is $6.50, so it's 6.50 times X. And then there's 12 tickets that are $4 each. 12 times 4 is 48. And you have to add them up to find the total amount of money that comes in. Okay?
We don't have the answers, we don't know what X.
Next, volume is length times width times height. So I take the three expressions and I just have to multiply them all. So I multiply the first two, double distribute, and I get 2x squared plus 15x plus 7. And then I need to multiply by the last side. So now I triple distribute. And I get, I believe my math is right. I could have made a mistake. Again, I do these lightning fast. 2x cubed plus 11x squared minus 23x minus 14. Okay?
Can we do the box math now?
Yeah, whatever floats your boat. Okay.
Wait, I'm still copying.
I wouldn't copy down. I would look on the
No, like
internet.
the final answer because I didn't
Okay.
understand it.
Now, this is a challenging consecutive integer question. This one does say consecutive odds, so I know I did it right. First one is x, next one's x plus 2. Sydney, pay attention. Next one's x plus 4. Then, here's the key to the whole thing. You have to read when it says the sum of, and I actually underline this part, because this is the part that you need to focus on. It says right here, the sum of the first, here's my first, 3 times the third, here's 3 times the third, is, equals, 2 times the second increased by 26. Once you write that, you can distribute everything out. I am going to slide the video forward so you can see the answer to the last question, and then you can watch the video tonight to learn how to do that. The homework tonight is finish that pretest, and we'll go over it tomorrow. Hasta la vista, vaya con Dios, toodaloo, ta-ta, arrivederci. Smile a lot, ciao, arrivederci, adios amigos y amigas. Cheerio, garushurus, kadafis. I'm sorry, what was that? You have to make your own diagram.
But I don't know where the shaded region is.
Oh, okay, well, does it give you the sides? Yeah, one fits inside the other, so draw the big one and draw the little one inside the other, and the shaded region is the area in between.
So I just have to subtract the two?
Yes.
Okay. Thank you.
You're welcome, have a great day, Lipstick.